Children, we have done chapter number 12. Now in your syllabus in the month of February, chapter number 12 and 13 are there, but 12 already completed, so 13 I am starting direct and inverse proportion. In direct and inverse proportion, what already you studied in 7th standard. Let us revise. Introduction. Mohan prepares tea for himself and his sister. He uses 300 milliliter of water, 2 spoons of sugar, 1 spoon of tea leaves and 50 milliliter of milk. How much quantity of each item will he need if he has to make tea for 5 persons? See here. For 2 persons, same quantity he will repeat. Then left, 1 person is left. So for 4 person, 300 milliliter of water. So 600 milliliter of water he will take. Water. And 1 more person, that means total 5, 150. Okay. So water 750 milliliter for 5 person. Okay. Now 2 spoons of sugar. So for 4 spoons and 1, 5. So 5 spoons of sugar. Now 1 spoon of tea leaves. So for 4, 2. So 2.5. Tea leaves he will use. And 50 milliliter of milk for 2 person. For 4 person, 100. And for 1 person, 25. So 125 milliliter of milk. So we calculated in this way. For 5 persons, 750 milliliter of water, 5 spoons of sugar, 2.5 tea leaves spoons, and 125 milliliter of milk. Okay, now next, if 2 students take 20 minutes to arrange chairs for an assembly, then how much time would 5 students take to do the same job? Now in this condition you can see. Now other condition. 20 minutes to arrange. If 5 students will arrange the chairs for an assembly, definitely the time taken by 5 students will be less than 20 minutes. They will arrange the chairs. Now see in the first condition, when the persons are increasing, the quantities are also increasing. In the second situation, if persons are increasing, then time taken by 2 persons and comparatively 2 persons, then 2 persons, 5 persons will take less time. So one quantity is increasing, automatically second quantity is decreasing. So in this chapter we will study about this. We come across many such situations in our day-to-day life where we need to see variations in one quantity bringing in variation in other quantity automatically. For example, if the number of article purchased increases, the total cost also increases. More the money deposited in a bank, more is the interest earned. As the speed of vehicle increases, the time taken to cover the same distance decreases. For a given job, more the number of workers, less will be the time taken to complete the work. Observe the change in one quantity leads to change in the other quantity. Write 5 more such situations where change in one quantity leads to change in another quantity. See here, if your mother is cooking food for 5 persons, then number of persons are increasing, then more food she will cook. So like this you will, if cleaning, suppose that one room is cleaned by 2 students, then 5 students will take less time to clean the room. So in that way you have to write 5 situations. How do we find out the quantity of each item needed by Mohan or the time 5 students take to complete the job? To answer such questions, we now study some concepts of variation. Now direct proportion. If the cost of 1 kg of sugar is 36, then what would be the cost of 3 kg of sugar? See children, we know very well. The quantity is more. In the lower classes we have learned when the quantity is increasing, definitely we will take the cost will be increased, so multiplication will be taken. That means one quantity is increasing, automatically second quantity is increasing. Here this concept we are taking. So 3 6 are 18, carry over 1, 3 3 are 9, 9 and 1 10. So it is rupees 108. Yes. Similarly, we can find the cost of 5 kg or 8 kg of sugar. Study the following table. See here, weight of sugar in 1 kg, cost in rupees 36. So 3 kg of sugar, 5 kg of sugar, multiply 36 multiplied by 3, 36 multiplied by 5. So you will fill the table. Here also 36 into 3, 36 in both the side. Okay, same way. Observe that is weight of sugar increases, cost also increases in such a manner that their ratio remains constant. You can see the cost of 1 kg of sugar we know, we are multiplying. When you will take the ratio of these two things, definitely ratio will be 1 upon 36. 1 upon 36, 3 1s are 3, 3 3s are 9, 3 6 are 18. Ratio will be same. Take one more example. Suppose a car uses 4 liters of petrol to travel a distance of 60 km. Take 4 liters of petrol to travel 60 km of distance. How far will it travel? Using 12 liters, definitely more quantity of petrol is there, so more distance will be covered for, by car. The answer is 180 km. How did we calculate it? Since petrol consumed in the second instance is 12 liters, that is 3 times of 4 liters. The distance traveled will also be 3 times of 60. So 60 into 3, 180. In other words, when the petrol consumption becomes threefold, the distance traveled is also threefold the previous one. Let the consumption of petrol be x liter and the corresponding distance traveled by y kilometer. Now complete the following table. See here, petrol in liter x 4 in 4 liters petrol, distance covered by car 60 km. Then 8, 4 2s are 8, 60 2s are. So ratio you will see here, 60 2s are. If in the 4 we are multiplying by 2, and 60 also we will multiply by 2. So 60 2s are 120. Then 4 3s are 12, 60 3s are. Then 15 here is. So for 15 what you will do? For 1 liter you can calculate, or ratio you can multiply 4, 1. So here when you will get, so you will do here. See here, 1, 4 1s are 4, 4 1s are 4 and 4 5s are 20. 1 upon 15. So this ratio you will do such as 15 1s are and then 15 will be remain. So 2 2 5. Same way you will fill the table. We find that as the value of x increases, value of y also increases in such a way that the ratio x upon y does not change. See here, in detail I am explaining. 4 1s are 4, 4 1s are 4. When you will divide 60 by 4, 1 upon 15. So this ratio will be when 1 upon 15. Then when we multiply by 15 into 15, so this 15 cancel by this 15, so 1 upon 15. So 15 into 15, 2 to 5. So easily we can tell here the value will be 1 upon 15, then we multiply 15 by 15, that means 2 to 5. So it is 1 upon 15. Check it. Yes, definitely. We say that x and y are in direct proportion if x upon y equal to k. That means constant value if we are getting, or x equal to ky. In this example, 4 upon 60, that means 1 upon 15. Check, it is also 1 upon 15. 12 upon 180. So 12 ones are 12 and 12 fives are. Where 4 and 12 are the quantities of petrol consumed in liters, x, and 60 and 180 are the distances, y in kilometers. So when x and y are in direct proportion, we can write x1 upon y1 is equal to x2 upon y2. That means same ratios. y1, y2 are the values of y corresponding to the values x1, x2 of respectively. The consumption of petrol and the distance traveled by a car is a case of direct proportion. Similarly, the total amount spent and the number of articles purchased is also an example of direct proportion. Now see here, think of a few more examples for direct proportion. You can think easily. Other way. Check whether Mohan in the initial example will take 750 milliliter of water. I already explained. 5 spoons of sugar, 2 into 1 upon 2 spoons of tea leaves, and a 125 milliliter of milk to prepare tea for 5 persons. Let us try to understand further the concept of direct proportion through the following activities. Now do this. Take a clock and fix its minute hand at 12. Okay. Minute hand in first on 12. Record the angle turned through by a minute hand from its original position and the time that has passed in the following table. T1 15 90 degree angle. Then if minute hand is at on 6 180 degree. In this way here 270 and then 360. Now T upon A you will find every time. First time I am finding for you 15 ones are 15 and 15 6 are 90. So every time you will calculate. What do you observe about T and A? Do they increase together? Yes. Is T upon A same every time? Yes. 1 upon 6 is the ratio. Is the angle turned through by the minute hand and directly proportion to the time that has passed? Yes. From the above table, you can also see T1 is to T2 equal to A1 is to A2. See here, 15 2s are 30, 90 2s are 180. So when you will take T1 is to T2, 1 upon 2, 1 upon 2. Then from here to here, when you will check, every time you will get the ratio 1 is to 2. So A1 is to A2 is equal to 90 is to 180 equal to 1 is to 2. T2 is to T3 is equal to A2 is to A3. You will check T2 is to T3 equal to, and this also you will check. Now I am checking for you this, you will check this. Okay, T2 is to T3. 30 upon 45. 15 2s are 3s are 2 is to 3. Now here 180 270. 3 6s are 3 9s are, then 2 3s are 3 2s are and 3 3. See, both are equal. So we can say that T2 is to T3 is equal to A2 is to A3. Now you will check. Check it, and you can repeat this activity by choosing your own time interval. Okay. So every time you can see the ratio is equal. Now you can repeat this activity by choosing your own time interval, ask your friend to fill the following table and find the ratio of his age to corresponding age of his mother. Friend's age 5 years ago, mother's age 5 years ago. So this you can do with your mother and then see. So this activity you will do and you will send on my personal WhatsApp number. What do you observe? You will observe whatever value or whatever your view is there, you will present. Do F and M increases or decreases together? Is F is to M same every time? No. You can repeat this activity with other friends and write down your observations. Okay, so you will do this yourself. Children, if you will not do the activity, then you will not get clear idea. That's why I am telling you, please, you will do this activity yourself. So you can repeat this, and in every situation the answer is no, you can see. Now turn the page. The variables increasing or decreasing together need not always be in direct proportion. For example, physical changes in human beings occur with time but not necessarily in a predetermined ratio. Changes in weight and height among individuals are not in any known proportion. If weight is increasing, it's not necessary height will increase. There is no direct relationship or ratio between the height of a tree and the number of leaves growing on its branches. Think of some more similar example. Now see here, observe the following tables and find if X and Y are directly proportional. See here, 20 ones are 20, 20 twos are 40. Then 17 into 2, 34, 14 into, so directly proportional. Now see, the 6 is to 4 ratio you will find. The ratio of this will be 3 is to 2. Now 10 and 8, 5 is to 4. Now 14 and 12, 2 sevens are 2 6, 7 is to 6. So ratio is not equal. Now X upon Y, 5 ones are 5, 5 threes are 15, 8 ones are 8, 8 threes are 15. Every time the ratio is, so in this 2 table, direct proportion, and this is not in direct. Now see here, principal, rupees 1000, rate 8% per annum. Fill in the following table and find which type of interest, simple or compound, changes in direct proportion with time period. Simple interest and compound interest. So let us start. Now see the formula of simple interest, P into R into T upon 100. So principal is 1000 rupees and rate of interest is 8 upon 100 and time is 1. So you can see here the simple interest is rupees 80. In this situation, for 2 years simple interest is rupees 160 and for 3 years simple interest is rupees 240. Now we will calculate compound interest. The formula of compound interest already we know, A equal to P in the bracket 1 plus R upon 100 to the power T, and then compound interest is equal to amount we will get, and from amount if we will subtract principal we will get compound interest. So for 1 year 1000 into 1 plus 8 upon 100 to the power 1, we never write power 1, but I am writing here to explain you, but you will not neglect it. Don't write. So 1000 into 108 upon 100, so amount will be rupees 1080. Then compound interest, when you will subtract 1000 from this amount, you will get rupees 80. Same way for compound interest for second year is rupees 166.40. For third year rupees 259.71. Now we will fill the table. Now you can see the table. For 1 year simple interest is rupees 80, for second year 160, for third year 240, and compound interest for first year, compound interest and simple interest both are equal. For second year compound interest is this, and for third year compound interest is this. So here the question is, fill in the following table, filled and find which type of interest changes in direct proportion with time period. So if T upon S we will take simple interest. So time is 1 upon 80. Second time 2, 80. Third time 240 divided by 3, 180. So every time same proportion we are getting, that means simple interest is. Now check with compound interest, 1 upon 80. Second time 1 upon 81 something. Third time 86 something. So variation is there. So think, discuss and write. So simple interest is direct proportion with time period. Think, discuss and write. If we fix time period, okay, and the rate of interest, okay, simple interest changes proportionally with principal. Would there be similar relationship for compound interest? No, because compound interest is changed every time. For second year, for second year if we will calculate interest, then principal will be, first year principal will be, we add something interest in original principal, and for second year we will assume the principal for second year, that one new principal. Okay, that means amount of first year we assume as a principal for second year. Let us consider some solved example where we would use the concept of direct proportion. So illustration you will solve yourself. You know that the map is miniature representation of every large region. When we draw graph, always we use scale 1 centimeter equal to 5 children, or horizontal line or vertical line. When we show distance or map, a scale is usually given at the bottom of the map. The scale shows the relationship between actual length and the length represented on the map. On the map we imagine the scale. The scale of the map is thus the ratio of the distance between 2 points on the map, the actual distance between 2 points on the large region. We assume a proper scale on the map. In short, for example, if 1 centimeter on the map represents 8 kilometer of the actual distance, if we want to change this 8 kilometer into centimeter, because units should be same, so 8 kilometers. So for changing the meter, 1 kilometer, in 1 kilometer 1000 meter is there, so 8000 meter, and then we will change 8000 meter into centimeter, we will multiply by 100. So 1 centimeter is to 8 kilometer, or we will write this is the standard form. 1 centimeter is to 1 times 100,000, 10,000, 100,000, 800,000 centimeter. Then 2 centimeter on the same map will represent 16 kilometer. Hence we can say that the scale of map is based on the concept of direct proportion. Now see, do this, take a map of your state, note the scale used there. Using a ruler, measure the map distance between any two cities, calculate the actual distance between them. So this activity you will do yourself, and you can see here also you can get idea, or from the social study also. Children, see, each and every subject is correlated. Anywhere you can see the use of other subjects also in the maths, in the English. So please do hard work and take each and every subject seriously.